Hello everyone, welcome to today's class. This is Teacher Simon taking you through IGCSE Extended Mathematics Paper 0580/42 for October-November 2025. And this is part 1 for questions 1 to 12. Question number 1, write the ratio 60 grams to 3 kilograms in the form 1 to n. Now you need to convert everything to the same unit. So this one will be 60, then to 3 times 1,000, okay? Because there are 1,000 grams in a kilogram. Since we see a 1 here, that means we divide all through by 60, okay? So I'll get this one here, then I will divide by 60 and then by 60 here. So we shall get a 1 here, then 2, this one dies, and then 6 goes into 30 5 times, so there is another 0. So that will be 50. So meaning here I will have a 50. Then question 2, solve this equation. We make x the subject of the formula. So take this on this side. When it crosses the equal signs, it becomes a plus. So plus the 17. Then this one gives you 44. And then to undo the multiplication here, we divide. So that means x is equal to 44 out of 8. And then here it will go in 5 times. That one will give us a 40. The remainder is 4. Now 4 out of 8, that is a half, which is 0.5. That means we shall have 5.5. And then question number 3, write down the order of rotational symmetry of a regular decagon for an n-sided polygon. For an n-sided polygon, order of rotational symmetry is always equal to n, okay? Is always equal to n, and n, those are the number of sides, okay? So if it is a square, it has 4 sides which are equal. So order of rotational symmetry is going to be 4. If it is a pentagon, 5 sides, so it will be 5. That is actually going to be the same as the lines of symmetry, okay? So lines of symmetry and order of rotational symmetry for any n-sided regular, by the way, that is very important. Regular, not every polygon, but regular. So that word regular, where all sides are equal, okay? Order of rotational symmetry, lines of symmetry will be equal to that n. So here, a decagon has 10 sides. That means we shall put a 10. And what is order of rotational symmetry? This is the number of times a shape remains the same as it is being rotated through 360 degrees. Question 4, Pedro makes cards. Then part A, he makes cards at a rate of 9 cards every 20 minutes. Work out the number of cards he makes in 8 hours. Now expectation here, we call it the expectation. This one is equal to NP, okay? So N, our N is 8 hours. How many times the experiment is done? So this is every 20 minutes. So you get the 8 hours, okay? The 8 hours, then times, these are 9 cards in every 20 minutes. So convert the 8 hours into minutes. So 8 times 60 minutes, okay? Then times, the probability here is 9 cards in 20 minutes. So this one goes here 3 times. Then this is 24 times 9. What do we get? 24 times 9. That is 216. So our answer here is 216. Then part B, each card costs 12 cents to make. Pedro sells each card for 50 cents. Work out his percentage profit. So percentage profit shall be equal to the profit. Then you divide by the cost price, the cost the cost price, and then times 100. So what is the profit? You get 50 minus the 12. The cost price is 12, then times 100. So what do we get here? 50 minus 12, that will be 38. Then divide by the 12. Then after that, we shall multiply by 100. We get 316.6 recurring, okay? 0.6 recurring. But to three significant figures, we can write 317. 317, three significant figures. Question 5. Noah is buying a phone. One website sells the phone for 953 yuan. A different website sells the same phone for $141. The exchange rate is 1 yuan, which is equal to $0.152. Calculate the difference between these phone prices. Give your answer in dollars, correct to the nearest cent. Now, I need to convert this yuan into dollars, okay? So 1 yuan, first of all, is equivalent to $0.152. That means 953 yuan. Then this one will be equal to the 953, then times the 0.152. So what do we get here? 953, then times 0.152. And then we get 144.856. Then the difference, we just get the 2 and we subtract. The difference will be 144.856, then minus the 141. So you get 3.856. Okay. Now, when they say nearest cent, they mean 2 decimal places, because $1 is equivalent to 100 what? Cents. So that means 1 cent shall be equal to, you get 1, then divide by 100. So meaning 1 cent is equivalent to $0.01. Are we there? So these are 2 decimal what? Places. So round this to this, you add a 1, so that means we shall have 3.86. Now, if you write your answer as 3.85, you get it wrong. If you write your answer as 3.856, the way it is here, you'll get it wrong because you have not rounded to the degree of accuracy they have given us here. Then question number 6. One morning, a dentist has appointments for 10 patients. The stem and leaf diagram shows the waiting time for 8 of these patients. Now, one of the key features of the stem and leaf diagram is that we have one number this side, okay? Here we can have a number, we can have 2 numbers, whatever. Then here, these numbers are increasing from the stem, because this is the stem, this is the leaf. So they are increasing outwards from the stem, okay? And these numbers are always aligning vertically. You see that? There is no number you're going to find that is in between. So if you are told to draw, then you should keep that in mind. And then we must have the key that represents what you have drawn here. We never have commas in here. We never have decimals in here. So if let's say these numbers are decimals, then it is going to be talked about here in the key. For example, this one here, then they can say 1/0 represents, let's say, 1.0 minutes. You see that? So please keep that in mind. Now, let's begin our question. So they are saying the times for the 2 other patients, P and Q, are not shown in the stem and leaf diagram. The mean waiting time of all 10 patients that morning is 16 minutes. The range of the waiting times is 26 minutes. Then patient P waits longer than patient Q. Find the waiting time for each of the patient P and patient Q. So what are we going to have here? We are going to use mean. How do you find mean? You get sum of all the data points divided by how many they are, not so? So meaning we are going to have, this is 0, 1. So 1, then plus 4, then plus, this will be 10, then 12, 10, then 12, then we have 19, then we have 21, there is 25, there is 25, they said 10. How many are these? These are 4, 5, 6, 7, 8. So we are remaining with those two. Let's say one is x, the other one is y. Are we there? Then we divide by, how many are they? They are 10. Then we equate to the mean. What is the mean? Mean is here, 16. So then we can cross multiply. What is this when we add everything together? So this is 50, then plus 10, that is 60. 65. Then this one will give us 40. That's 105. 105, then plus the 12. 105 plus 12, that's 117. So we have 117, then is equal to, plus xy, plus x, then plus the y, then is equal to 160. Okay, so meaning x plus y then shall be equal to 160 minus 117. 60 minus 17, don't you get 43? So x plus y will give us 43. Now, they said that the range of the waiting times is 26. And to get range, you get the highest value minus the lowest value. So the highest value is 25. Then minus the lowest value, which is 0, 1. That means you get 24. But this one is 26. That means one of these two values we are looking for is greater than 25. Okay? And that one has to be, how do you get 26? Then it has to be 27 here. So if you have 27 minus the 1, then you get the 26. So one of these numbers is 27. Okay? So I will say range is equal to the biggest value. By the way, let me define my x and y. Okay? X, this is for the waiting time for patient Q. Okay? Not patient P. Then y is going to be the waiting time for patient Q. And they said that patient P waits longer. So that means x is greater than what? Y. Now range then shall be equal to the smallest value, biggest value minus the smallest value. Okay, now our biggest value then has to be x. This is 26, because I said that when you get this 25 minus the 1, you get 24. You're not getting 26. So meaning one of these numbers is the one that is the biggest. Okay? And we have seen that it is 27. But this is minus, the smallest value is 1. So bring this one this side. That means 26 plus 1. Then we'll give you the x. And x becomes 27. Is that clear? So waiting time for patient P will be 27. Then here, this implies that our y then shall be equal to 43 minus the 27. And this one will be 16 here. That is the waiting time for patient Q. As simple as that. Question 7. The diagram shows a parallelogram. The parallelogram has the same perimeter as the circle with radius 4 meters. Show that x is equal to that, correct to 2 decimal places. Okay. Now they say that perimeter of the parallelogram is equal to the perimeter of the circle. Now perimeter of the circle is the circumference. Okay, perimeter of the circle, let me put it here, it's the circumference, which is given by 2 pi what? R. Now perimeter of the parallelogram, I'm going to get this plus this plus this plus that, not so? So we have 6.51 plus x. All of them are appearing 2 times. So I'll do that. Then I'll say this one is equal to 2 pi. And then the r is 4. So make x the subject of the formula. Divide all through by 2. So 6.51 then shall be equal to, plus the x then shall be equal to, when we divide all through by 2, then this one will become 4 pi, not so? Then take this one this side. Our x will therefore be 4 pi, then minus the 6.51. So what do we get here? 4 pi minus 6.51. So that is 6.05, and the rest of those figures, but to 2 decimal places, that will be 6.06 meters to 2 decimal places. As simple as that. Then next, part B, the floor of a room is in the shape of this parallelogram. It costs $18 per square meter to tile the floor. Calculate the total cost of tiling the floor. Now we need to find area of this parallelogram. Okay. Now, do we know this here? The height of this parallelogram. Since this one is a right angled triangle, okay, then we can use SOHCAHTOA to find this height here. Are we there? Okay. Now, relative to this angle, this one is going to be the opposite. This one is going to be the adjacent. Opposite and adjacent are always perpendicular. Then this becomes the hypotenuse. Okay. So this one here is going to be my height of the triangle. So using SOHCAHTOA, remember, whenever we are using SOHCAHTOA, whenever we are given a right angled triangle, that is when we can use SOHCAHTOA or Pythagoras theorem. We use SOHCAHTOA if there is inclusion of an angle. So our height here, relative to this angle, so we have opposite, this is adjacent and then hypotenuse. So adjacent and hypotenuse, don't we have cosine? So cosine of 36 degrees is equal to the adjacent, which is our h, then divide by the hypotenuse, which is 6.06, then cross multiply. The h is going to be 6.06, then the cosine of 36 degrees. Okay, then area of parallelogram, it is like the same as area of the triangle, the rectangle. So we have the 6.51, then times this height here, which is 6.06, then the cosine of 36 degrees. Okay, now what we are going to have here, put everything here, this one is going to be in square centimeters. Square centimeters, square meters. It has to be in square meters because we have a meter and then a meter, not so? But then they say that it costs $18 per square meter. That means the cost shall be equal to this value we have gotten here, then times the $18. So what do we get all together? 18 times 6.51 times 6.06 cosine of 36. Again, the calculator in what? In degrees. Then we have 574, then 0.49, and the rest of those figures. Okay, 574. Then we can round this one off to, or you can say 574 Okay, 574.49. So for answers in dollars, you can give them to 2 decimal places, because cents are there, they are also given. But you can write, if you write 574, that is to 3 significant figures, that one is okay. 574, this is 3 significant figures, it is okay. Okay, or you can write 575. Someone rounds this off to the 5, but that one is going too far. Question 8 is coming from transformations of functions, part A. On the grid, draw the image of Roman 1 shape A after a translation of 1, 7. That means here, move 1 unit to the right, because X is positive going to the right, and then negative going to the left. And then this one represents the Y movement. So we move 7 units. Y becomes negative when we are going down. 7 units downward. Okay. Then, if it is positive, then we go up. So every point on that shape moves like that. So shape A, we are moving 1, move it here, then 1, 2, 3, 4, 5, 6, 7. So I will put this one here, then move that like that. Then from there is this one going like this. Then there is one here like that. Then you connect this one to that. Okay, so that is what we are having there. I'll take off this like that, and if possible, then I can do that, and then also that to show the movement. But then I'm going to make it so much dotted that it doesn't interfere with what was given to us. So like that. These are 7 units. This is 1 unit. And that will be that. Then I will actually write here, this is A, then Roman 1. Then Roman 2 shape A after a reflection in this line. So this line here, X plus 1, you get like 2 coordinates on it. So X here, when X is 0, Y will be 1, not so? Then Y, when Y is 0, put 0 here, then bring 1 this way, it becomes a negative. So negative 1. So we have 0, 1. 0, 1 is here. Then negative 1, 0 is on the x-axis, which is here. So we draw a line all through. Okay. It will be like that. So this one is just going all through like that, through the diagonals. So I'll shift it a little bit and put it there. And then I will also make it a bit dotted. It was not given, such that it doesn't interfere with our grid. Now, better, you can even add on this to show that this one is a reflection line. Then you even label it, okay? So that is X, Y, which is equal to X plus 1. Then from there, when we are reflecting, the object and the image must be equidistant. Object and image must be equidistant from the mirror line, okay? Now, and the line connecting the object and the image must be perpendicular to the mirror line. What do I mean? So you can see that this line here is going through the diagonals. You see this diagonal here, diagonal here, diagonal here. That means the line also going to connect the object points to the image points must also be going through the diagonals like that, like that, like that, like that, like that. You see that? So let's count now. 1, 2, 3. Those are 3. Then you move this way. 1, 2, 3. So it will be here. Okay. So we have 1 here. Then we go. This one here. 1, 2, 3. Again. 1, 2, 3. So we shall have 1 here. Then how about this one here? 1, 2, 3, 4. 1, 2, 3, 4. So it will be here. Then how about this one? 1, 2, 3, 4 and a half. Then a half. 1, 2, 3, 4. So it will be here. Okay. Then now you can connect them. You get your ruler. Please don't connect them using your free hands. Don't do such errors. That is what we are having. And this is A, Roman 2. This is A, Roman 2. And then next, describe fully the single transformation that maps A onto B. So for description, I have always said, look at the number of marks given here. If it is 3, then you talk about the enlargement. You tell us that it is enlargement, give us the scale factor of enlargement and then the center of enlargement. Okay. Then you can also talk about rotation. Okay. Rotation through, give us the angle and then the direction, like maybe rotation through 90 degrees clockwise. Then how about the center? You see? So when you look at these two, they are congruent. So that means it cannot be enlargement. That one is going to be rotation. So we shall put rotation through which angle? We put the angle, then the direction. Now when you look at this one here, this one is this one here. So it was horizontal, now it became vertical. So horizontal, then the other one, the corresponding one, is vertical. What is the angle in between the two? Is 90, not so? And I think this one here came like this. The way, if you can look at this one here, you cannot just bring it like this. It has to be like this. So we are moving anti-clockwise, not so? So through 90 degrees anti, or you can say counterclockwise. Okay, anti-clockwise. Center, you have to tell us the center. Which center? So we do this by constructing perpendicular bisectors of lines connecting the object points and image points. Okay, then where those two perpendicular bisectors meet is the center of enlargement, is the center of rotation. Okay, let me write it even here. I'm going to look at the corresponding points. So we have this one here and this one. You see that? Then I'm going to connect them. So this one connects it to this. Then you construct a perpendicular bisector. Okay, so you get your compass. Mine is here. And then you try to make sure that it goes beyond the midpoint of that line segment you have drawn. So I'll put it at this point. Then after that, so let me try to, now this one is beyond this line. So you have to be careful. It has to be at least beyond the midpoint such that the arcs can meet. Okay. Then let me put this one back here. We shall have this one here, then another one drawn up here. Don't tamper with the length of that compass. Okay, we draw that, then you bring it down here. You also do the same. So you draw this one here, then you go also up here, and then you draw an arc there. Then you connect the two where they have met. Okay, so you put your ruler and then you draw that. Then again you get another point, you construct, and then you see where they meet. Okay, so which other one am I going to use? I can use this one here. This one corresponds to this other one here, not so? So let's connect and then we also draw. So connect this to that, Then you put your compass again. So I'll put my compass here. Then after that, I will draw an arc down here. So when you draw the arc down here, then don't tamper with that compass. Rotate it, put it up here. You also draw another arc there. In fact, to avoid doing errors, let me change the color such that you can see the arcs very well. Okay, so I'm going to draw an arc here. Then I also come down here, and then I draw another arc. Okay, another arc there. Then don't tamper with the compass. Now bring it this other side here. Okay, place it here. Then you draw an arc again. In fact, that is too long, so let me repeat this. It's too wide, so we have that. Then don't tamper with the length of that compass. Bring it up here. Then you also do the same. Now where those two meet is going to be you connect those two arcs where they have met. Now these two lines you have drawn are going to meet at a certain point here. You see that? This point here, it corresponds to -2 and 6. So this one here is the center of rotation. So I'll go and write here, center is -2 and then 6. So we have a mark here, there is a mark here for the angle and the direction, then the center. Okay. Question 9, the diagram shows speed-time graph. Okay. Then find the total distance. You know that total distance on a speed-time graph is equal to the area under the graph. So the distance is equal to total area under the graph. Now this is a trapezium, so I can say a half, then h into a plus b. Then there is a triangle here. That is a half base times height. Now let us look at the height of this trapezium. The height of the trapezium, that is the distance between, or the length between the two parallel sides. So this is 15. So that is 15. Then A and B, those are the parallel sides. So we have this one as 60. But then you have to be very, very careful. The speed here is given in kilometers per hour. The time here must be in hours if this is kilometers per hour. Okay, so but the time here is given in minutes. That means you have to convert these minutes to hours. So here I will divide by what? 60. Are we there? Because these are minutes. Then I can take hour B to be this one here, which is 80. So plus the 80. Then for the triangle, it's a half times the base is 25 minus 15. So 25 minus 15, that will be 10. But you divide it by what? 60, because this one has to be in hours. Then times the height, here it has to be 80. So times 80. Okay. Now we can put everything in the calculator and then we simplify that. Not so. The first one is 15, then divide by 120. And then we multiply by 60 plus 80. Then after that we add 0.5, that is a half, then times, I think that will be 1 out of 6. Okay. Then times 80. So altogether we get 145 out of 6, which is 2.16 recurring. So I can just put, I can leave it as a fraction, which is 145 out of 6. Or we write 2 point, no, not 2. It is 24.2. That is to 3 significant what? Figures. You choose one answer you write, okay? Don't write both. In fact, let me put this one down here. Then next we have question 10. Find the nth term of the sequence. So what do we see here? If we subtract 8, okay, again here minus 8. So minus 8, this is then a linear sequence. So the nth term is therefore going to be equal to A, then plus n minus 1 D, where A is the first term and then D is the common difference. How do you get the common difference? Get the following term, then minus the previous term. So our first term is 17, then plus n minus 1, and then our common difference is negative 8. Now open the brackets. You have 17 minus 8n plus 8. So we shall get 17 plus 8. That is 25. So I'll write 25, then minus 8n. And then part B, we are seeing here 3, then 12, then 27, 48, 75. So what do we see in here? Okay, we can see that this one here is, what's the difference? The difference is 9. Then here, 27 minus 12, that will be 15. Then from here, we are getting 21, okay? And then here, we are getting, so this is another sequence. I can see here there is, what is added here? A 6, then even here is 6. That means even here we shall get a 6. So that is 27 here, if you get 75 minus 48. Now this is a quadratic. This is a quadratic sequence. So the moment you see two sequences, you get the constant, the common difference, the constant one here. You see it at the second subtraction, then that means this is a quadratic what? Sequence. Okay, and its nth term is equal to a n squared, then plus bn plus c. You see that? Then how to get this one here? This one is given by 3a. No, I mean 2a, then will be equal to that 6. So a becomes a 3. Okay, these are the three formulae we use. So second difference is given by 2a. Then if you get the first term minus the second term minus the first term. Okay, so let me take away this one. It has to be second term minus the first term, then this one is equal to 3a plus b. So this is the one here. So that means we have 3 times our a, which is a 3, then plus the b, then shall be equal to the 9, which is here. Then what will be our b? B will be a 0. Then the other one we use is that the first term, I did all of these in the papers that we have been doing before. Please check through the channel. So the first term, that is when n is equal to 1. So when I substitute 1 here, you'll get a plus b plus c. So we have our a as 3, our b is a 0, our c, we don't know it. Then this one is equal to, what is a? A is 3 here, 3. So that means c will be also equal to 0. So the nth term, when you substitute, we only have the value of a, the rest are zeros. So we shall have 3n squared. And by the way, if this is a quadratic sequence, then we see a connection between the square numbers. So square numbers must be in here. Square numbers, we have 1, we have 4, we have 9, we have 16. You see that? Now, if we multiply this one by 3, you'll get a 3. Multiply this one by 3, you get a 12. Multiply this one by 3, you are getting a 27. Multiply this one by 3, you are getting a 48. So these are the terms we are having, and this is n squared. This is the other way you can do that. So terms, no, actually I can have position n. So this is 1, 2, 3, and 4. You see that? So this is the alternative approach. You can simply get your answers here. So the position So the position we are talking about here is this is position 1. Which term is in position 1, then position 2, like that. Okay, then we square them, we get this. We square them because we have seen that we are getting a common difference on the second what? Subtraction. Okay, so that is what we do, and that is that. So if you see a connection between the square numbers and then the terms given, that one will give you the what? The nth term. Question 11 is coming from graphs. The table shows some values for y is equal to x cubed minus 2x plus 3. Where appropriate, values of y are given correct to 2 decimal places. And then part A, we are told to complete the table. So that means we need to find the values of y when x is negative 1.5 and when also it is 1.5. So I will get my calculator and substitute. We have the negative 1.5, then cubed, minus 2, and then negative 1.5, then plus 3. This one gives us 2.625, and we can write this as 2.63 because they said where appropriate, we correct to 2 decimal places. Then when x is equal to 1.5, I will just come back to this and then remove the negative. Then after removing the negative, I'll be having 3.38. 3.38. And that is that. Then draw the graph of this. That means we plot. But we need to know the equivalence of a small box before we plot. Okay? On the horizontal axis, one small box is equivalent to, this is 1 unit. They are adding on 1 unit every now and then. So 1 divided by, how many small boxes do we see? These are 10, then 20. So that means this one is 0.05. Okay. Then, of course, on vertical axis, one small box is equivalent to 1 then out of 10, which is 0.1. Now, let us plot negative 2, negative 1. So negative 2, negative 1, that one is here. So I'll put a small dot and then a circle. Then next we have negative 1.5, 2.63. Negative 1.5 is here, 2.63. So this is 2.6. Then 3, it is almost in the middle. So I'll say maybe it is just above. It will be here. Then next, negative 1 and 4. Negative 1, then 4. So the point is here, like that. Negative 0.5 and 3.88. 3.88. So this is 3, then 0.8, then 8, almost at 3.9. Okay. So around here. So the point is around here. Then next 0.3, which is this one here on y-axis, and then 0.5, 2.13. 2.1 is here, but 2.13, it will be just slightly above. Next, 1, 2. 1 and then 2 is the one here. Then 1.5, 3.38. 1.5, 3.2. 3. That is 3.1, then 3.2. Then 3.3 will be in the middle. No. 3.3 is here, almost at 3.4. So I'll just put it around here, just below 3.4. This is too big. It has to be a very small circle, like that. And then to 7. To 7 will have to be here, the very end. Then we connect all of those points and we produce a smooth curve. But since this one is a cubic function, okay, it's a cubic graph, you can find where it is crossing the x-axis. Okay, so let us put in the calculator such that when you are connecting, you pass through that point. That is how you can cheat the examiner here. So we go to mod, then equation, that is 5, then cubic is the last one, that is 4. Now when we look at our equation here, our a, that is the coefficient of x cubed, it is a 1. Then the coefficient of x squared is the b, it is not there, so it is 0. Then we have the coefficient of x, that is a -2. And then the constant is a 3. Then we get -1.89. So -1.8 will be here. -1.5, 0.6, 0.7, 0.8, 0.9. So it's almost here. Okay. So it's almost here. So on the 0.9. So I'll mark a small point there. Then I take with this. Just mark a small point there. Then the other point, I think it is nowhere because this one is coming like this and then it goes. So the other values are complex. They are not real. It is not crossing x-axis again. So that is that. Then now let us join. So when I'm joining, I make sure that it passes through that point there. You get it? So we go, but try your level best to produce a smooth what? Curve. Like that. You come like that. And that is that. Then part C, by drawing a suitable straight line on the grid, solve this equation. Now what we have to do is to get this equation here. We use this equation to solve the other one. Okay, so what we are going to do, this is x cubed. So I'll say y is equal to x cubed, then minus 2x plus 3. Then I'll bring this one here. It is x cubed minus 2.5 of x, then plus 1. And this one is equal to 0. Then we subtract. I'm solving this from this. So we subtract. Then we get an equation of a straight line. So y minus 0, that is a y. Then x cubed minus x cubed, that one goes. Then -2 minus 2.5. Then that one will give you -2, then plus the 2.5, which is a 0.5, not so? So we shall get a positive 0.5 of x, and then 3 minus 1, we get a 2, not so? This is now the equation of a straight line you have gotten. So you draw, you get just 2 coordinates. Okay, I mean 2 points, you get their coordinates and then you plot. So when x is 0, y will be 2. You see that? Then when y is 0, so if this one is 0, bring the 2 here, x will be a 4. I mean a -4, you have a 2, then divide by the -0.5, that will be a 4. But on our grid, do we have a 4? For the x, we do not have a 4. We are moving from -2 to +2. So what we have to do is to look for any other. Let's say now that x is, let x be 1. if I put 1 here, so 1 plus the 2, that is 2.5 for y. Then I can plot these 2 points, 0, 2. So I have 0 and then 2, which is on y-axis. This is the one here. And then the next one is going to be 1 and then 2.5. 1 and then 2.5. It is here. So I plot that. I plot that point there. Then I draw a line that is going through these 2 points. Oh, so we can even go, this is 1, 2, then 1. No, these are 2, then 4, then 1. So that is that. We go 1 unit, then 0.5 units there. So that means we shall go 1 and then so we go 4 smaller boxes, then 1 down. So that is how you locate the other points. So there is 1 here. Then again you go, how? You move 4, then 1, like that. So I'll have a point here and then another one here. You see that? So when I get my ruler, I can just begin from this side, then connect through these. You'll find that all of these points, even the other 2 that I found in the table, they lie onto that line. You see that? Then you label. This line here is equal to 0.5x plus 2. 0.5x then plus 2. That's the equation of our line. In fact, let me shift it. Maybe put it there. And then you can see that this equation here is meeting this graph, this curve at 3 points. So we need to check this point here. We need to check this one here. And then also this one here. Is that clear? So that means they must have left 3 spaces. You see? They are the ones here. So now let's check and we see what we have. Now this one is this one here. So let me draw a line there. Then we go down. We are having a straight line, I mean a point here. And let me make it a little bit dotted so that it doesn't interfere with what was given there. Then the next one here is there. This one here, we also do the same, make it dotted. So you can see that this one is 0.5, no. 0.5 is here. So this is 0.01, 0.1, 0.2, 0.3, 0.45, okay? That is 0.45. In fact, I can go the other side and I write this one here, 0.45. Then here, this last one here, this is 1.1, 1.2, 1.25, not so? 1.25. And then here, so we come to this side, then we see where these 2 are meeting here, somewhere there. So this is negative 1.5, negative 1.6, negative 1.7. This will be 7.5. So maybe 7.3, negative 1.73. That is what I'm going to write. Negative 1.73. Now this one has gotten a range of values. So your answer here should be negative 1.5 to negative 1.7. So mine is negative 1.73. So I'm in this range. That means I can get it correct. And then here it is 0.4 to 0.45. Why do they give you these ranges? It's because not all of us are going to produce the same points here, the same smooth curve. Okay, another person can plot and then the curve comes like that, you know, it's not so smooth. So they give that allowance because of the difference in producing the smooth curve. Then this other one here, it is from 1.25 to 1.4, and all my answers lie within the ranges, so therefore I'm correct. See, you write what you have gotten, not what you think it must be. Okay, then next, because another person, like the way I've shown you how to solve it on the calculator, someone can put this one on the calculator and then they get the answers, then those are the ones they write here. No. You write your answers which you have gotten here from the graph. That is why they are saying by drawing a suitable straight line on the grid, then solve. So you must use we must see a line drawn. So if we don't see this line drawn on the curve, then we are not going to give you any mark. You see that? Because this is the basis for the marks that are supposed to be given to you. Question 12 is coming from circle theorems and properties. A, B, and C lie on a circle of center O. DE is a tangent to the circle at C. Angle ABC is equal to 52 degrees and angle BCE is equal to 65 degrees. Then part A, find the value of X and give a geometrical reason for your answer. So here the geometrical reasons, we are supposed to give the circle theorems or properties. Okay. Now they want the value of X, this one here. I want you to look at this point A and point C. Okay. So we look at these lines connecting them to the center. So this one is called angle at the center. But again, come back to C here and A. Then you look at this chord connecting to the circumference of the circle. Again, come back here. So these two are always connected. This angle here at the circumference is connected to the one at the center. In other words, the one at the center is twice the one at the circumference. Okay. I did a video on this channel explaining circle properties and theorems. So please check it out. So X is going to be 2 times the 52, which is going to be 104, because we shall say that angle at the center, that is the theorem, angle at the center is twice angle at the circumference. At the circumference, and that is all for this. Part B, find the value of Y. Now this one I can find it in two ways. Okay, if we have a tangent to the circle and then we have this chord here that forms an angle with the tangent. Okay, so we look at this chord here connected to this other one and then this one, so they form a triangle. So always this angle here formed between the tangent and the chord, we look at the segment within which it lies. Are we there? Then we look at the angle that is opposite to this segment, this angle here, this whole angle. So this one is going to also be equal to 65 degrees. You see that? That is what we call alternate segment theorem. Okay, alternate segment theorem. Now after that, we can, how can we then find the value of Y? So since the whole of this is 65, but this one is an isosceles triangle. You see that? So if it's an isosceles triangle and we already have this one as 104 degrees, then we can find these two angles. You see that? So after finding those two angles, then that means I'll get my y by getting 65 minus this angle. Is that clear? Okay, so let's go. We shall say the value of y here. So I'll begin by finding angle OAC. Angle OAC is equal to 180 minus 104, then divide by 2. Which geometric reason am I giving here? They haven't asked me for the geometric reason, but what am I using here? This is an isosceles triangle. I'll just put isosceles triangle. Base angles of an isosceles triangle are always equal. So the base angles we are talking about this and this. Then here we are going to get, what do we get here? 76 divided by 2. That one is going to be 38, not so? So this one will give us 38 degrees. Then after getting that, so this simply implies that y then shall be equal to, first of all, I'm going to say angle BAC. Okay, angle BAC is equal to 65 degrees. Geometric reason here is alternate segment theorem. You see that? Then next, we shall now get our value of y, which will be that 65, then minus the 38 degrees. So here I only need to add 22 to go to the 60, then plus the 5, then that will be 27 degrees. And that is that.